This is a presentation on divisibility and congruences by V. Hinduja, Assistant Professor, Department of Mathematics, St. Joseph's College for Women, Tirupur. Divisibility. We consider a non-zero integer a and an integer b. Then we say that a divides b, or b is divisible by a, or b is a multiple of a if there exists an integer x such that b is equal to ax, and we write a divides b. For example, 2 divides 6, since 6 is equal to 2 into 3. If a divides b, which is positive and less than b, then a is called a proper divisor of b. Here 2 is a proper divisor of 6, since 2 lies between 0 and 6. Greatest common divisor. If an integer a divides both the integers b and c, then we say that a is a common divisor of b and c. If at least one of b and c is not 0, then the greatest common divisor, that is GCD of b and c, is the greatest among their common divisors, and we denote the GCD by b comma c inside a parenthesis. So for n integers b1, b2, etc. bn, not all 0, the GCD is denoted by b1, b2, etc. bn inside a parenthesis. For example, 3 is a common divisor of 18 and 24, since 3 divides 18 and 3 divides 24. Whereas 6 is the greatest common divisor of 18 and 24. Relatively prime. We consider two integers a and b. Then we say that a and b are relatively prime if GCD of a comma b is equal to 1. If we consider n integers a1, a2, etc. an, then they are relatively prime if GCD of a1, a2, etc. an is equal to 1. If the integers a1, a2, etc. an satisfies the condition GCD of ai, aj is equal to 1 for all I and j with I not equal to j, then they are said to be relatively prime in pairs. For example, 8 and 9 are relatively prime since GCD of 8 and 9 is 1. Least common multiple. We consider the non-zero integers a1, a2, etc. an and an integer b. Then b is said to be the common multiple of the integers a1, a2, etc. an if ai divides b for all I equal to 1 to etc. n. For example, 60 is a common multiple of 2, 3 and 5, since 2 divides 60, 3 divides 60 and also 5 divides 60. The least of the positive common multiples is called the least common multiple, and it is denoted by a1, a2, etc. an inside a square bracket. For example, 30 is the least common multiple of 2, 3 and 5. Prime and composite number. We consider an integer p greater than 1. Then we say that p is called a prime number or simply prime if it is divisible by 1 and itself. In other words, we can say that there is no divisor d of p satisfying 1 less than d less than p. For example, 5 is a prime number. If an integer is not a prime, then it is called a composite number. For example, 15 is a composite number. Congruent modulo. We consider the integers a and b and a non-zero integer m. Then we say that a is congruent to b modulo m if m divides the difference a minus b, and we write a is congruent to b modulo m. If m doesn't divide a minus b, then we say that a is not congruent to b modulo m. For example, 11 is congruent to 1 mod 2 since 2 divides the difference 11 minus 1, that is 2 divides 10. Complete residue system. First we will see what is called a residue. We consider three integers x, y and m. If x is congruent to y mod m, that is if m divides the difference x minus y, then y is called a residue of x modulo m. Next we consider a set of integers x1, x2, etc. xm. Then this set is called a complete residue system modulo m if for every integer y there is one and only one xj such that y is congruent to xj modulo m. For example, a complete residue system modulo 8 consists of a set of integers 0, 1, 2, etc. up to 7. Since If any integer is divided by 8, we get the remainders, that is the residues, 0, 1, 2, etc. up to 7. In general, the set 0, 1, 2, etc. up to m minus 1 is a complete residue system modulo m. Reduced residue system. We can simply obtain a reduced residue system modulo m from the complete residue system modulo m by deleting the members that are not relatively prime to m, or by choosing the members that are relatively prime to m. For example, we have the set 0, 1, 2, etc. up to 7 is a complete residue system modulo 8. Since 0 is not relatively prime to 8, 0 is not in reduced residue system modulo 8. Since 1 is relatively prime to 8, 1 is in reduced residue system modulo 8. Similarly, we have 3, 5, 7 in this set reduced residue system modulo 8. Therefore, the set 1, 3, 5, 7 is the reduced residue system modulo 8. Thank you.